about the liquids. Okay, this is about the solid. Even one more point I have to tell you: solids have a more density. We'll did study about the density in the liquid session. Okay, what is a liquid? It is defined as the form of matter which possesses fluidity, but it is almost incompressible and hence has a definite volume but no definite shape. Keep in mind that liquids have definite shape but no definite what you call the volume, definite volume but no definite shape. Liquids have a definite volume only but not definite shape. For example, if you take a 1 liter water bottle, uh, if you add that 1 liter in any other container, the volume of that 1 liter remains same, but the shape will be different. If you 1 liter bottle, if you add in another container, it takes the shape of container. If you add in a bowl, it takes shape of bowl. If a vessel, if you add, it will take the shape of a vessel. Here what we can say, solids have a definite shape and definite volume, but liquids doesn't have a definite volume, but liquids have a definite shape. Then we'll discuss about the properties of liquid one by one. So first property, liquids do not have a fixed shape but have a fixed volume. We'll learn about this. The why it is. Okay, the interparticle force of attraction in liquids. The interparticle force of attraction in liquids are strong. For example, in solids, as I shown you in blocks, here all particles are gathered compressedly. All particles are tightly arranged, so that there is no interparticular space in a solid. But here the interparticle force of attraction in liquids are strong, that they have fixed volume, but these forces are not strong to keep the particles in fixed position. See, in solids, these interparticle forces are very strong. In between, we will not get any space. I will show the video that how the particles are arranged. These interparticle forces are not very much strong comparing to the solids, so that the forces are not strong to keep the particles in fixed position. Therefore, liquids do not have fixed shape. They take up the shape of the vessel in which they are placed. Even the particles are fixed here, but not very much fixed like solid. That's why it can flow easily. Liquid can be flow easily, like water or rivers, how it flows, it will flow like a wave. But if you throw a stone, it will flow, no, it will breaks. So liquids can flow because it have the property of flow. Liquids do not have definite shape. Because of this definite volume, it can flow easily. Next point, liquids are not rigid but have the property to flow due to large interparticle distances and weaker forces. See here, I told you about liquids. See, if the solid interparticle forces are very much smaller, but here the particles have a very much large interparticle spaces. See, if you see here, the interparticle spaces between particle, if you see the gap here, but in solid we will not see any gap here. So due to larger interparticle distances and weaker force of attraction than in solids. So if you particle spaces are weak, and if more space will found in between the particles, then this will call as force of attraction is weak. So due to this weaker force of attraction, liquids can flow easily, and it can change the shape of any container, or it can change shape of any vessel. So relative fluidity differs from one liquid to another. Even the flow nature also different from one substance to another nature. See, as you saw that water can flow very fast, but honey or milk can flow very slow. That's why rate of flow also differs from one liquid to another liquid. The next, third property of a liquid, liquids have low density than solids. It's a very important concept. Listen clearly. Due to larger interparticle distances, liquids have a lower density. See here, as I shown you here, the interparticle distances are very large. Due to this large interparticle spaces, liquid can float easily, or even liquid have a lower density than solids, but much higher than those of gases. If you compare it with the solid, less what you call the density is less, but if you compare to the gases, it has more density, we can say. For example, liquids generally have lower density, as I told you. Solids have density more. What is the density? Mass per unit volume. For example, if you take an iron and a cotton, iron is weight more because it has mass per unit volume. Even all particles are arranged tightly, and in cotton the particles arranged little loose. Here the solids have a stronger density, but the liquids generally have lower density as compared to solids. But if you add ice on a water, or when you throw ice on a water, ice floats on water. Why? Ice is a solid, it has to sink inside. Why it will float? Even though ice is being a solid, it will not sink, because ice being a solid, due to its specific structure, it has larger interparticle spaces. Very important point. Ice has inside the particle of ice very much large spaces will found, and hence has lower density than liquid water. As a result, ice floats on water. Because of less density inside the ice, it can be float easily. See, if I say one point, um, the density of ice, if it is lesser than the water, ice can float. If any substances which will float on water, if that density is less, then it can flow easily. Even if you, I think you heard about the Dead Sea. Even if you sink in Dead Sea, you cannot sink there, you can float there. A very interesting point. Why? Because it found in between that Israel and Jordan. Just search there, you will get. Or else I thought you know about that. See, Dead Sea, why we cannot sink there? If you even jump, it floats. Why? Because the density of water is more than our body weight. If any substance's density is more than our weight, then we will not sink. We will float in that substance, that water or liquid. Okay. The next concept, next point. Liquids possess the property of diffusion. It's very important. I told you about the diffusion in the previous class. Intermixing of particles. Or even the gases will diffuse very fast. Okay, as I told you, I gave you example of agarbatti, incense stick. If you kept in a corner, you will get a smell even from a far distances. Okay, even liquid also possesses the property of diffusion. Due to larger interparticle distances in liquids than in solids, the particle of a liquid have more freedom of motion than those of solids. Therefore, solids, liquids and gases all can diffuse into liquids as follows. See here. We'll see how the diffusion occurs in a solid into liquid, liquid into liquid, and gas into liquid. We'll see one by one. So first one, diffusion of solid into liquid. Uh, when you take a crystal of copper sulfate or potassium permanganate, when you add it to water, the particles of copper sulfate or potassium permanganate quickly diffuse in between the particles of water to form the homogeneous solution. Not only that, even we saw about in a previous video, when we add potassium permanganate in a hot water, it diffuses faster, because solid can diffuse in a liquid very fast, even with increasing temperature. Okay. Second one, diffusion of liquids into liquids. It is an example. Even copper sulfate, potassium permanganate, if you add, or ink, if you add in water, ink will call as even ink powder, which will call. If you add, it will diffuses easily. It is an example of solid into liquid. Then even sugar and salt dissolved in water, also diffusion of solid into liquid example. Then which is what is diffusion of liquid into liquid? When water is added to alcohol, or vice versa. Vice versa means when you add water to alcohol or alcohol to water, the two liquids quickly diffuse into each other to form a homogeneous solution. See, if you add water into the alcohol, it diffuses very quickly with each other. Means liquid can diffuse in a liquid itself. Next, third one is diffusion of gases into liquids. This we know that some gases like oxygen and carbon dioxide from the atmosphere diffuse into water, that is dissolved in water. See, as you know that these gases are essential for the survival of aquatic animals and plants. What we are taking oxygen, it is in direct form, but the fishes which are in the water, it will take oxygen which are present in the diffused state. In aquatic animal, in aquatic place or in water, those animals which are present in water, they will not get oxygen directly. The oxygen which will be diffused in the water, those diffused oxygen will be absorbed by the aquatic animals. The aquatic animals can breathe underwater due to the presence of dissolved oxygen in water, but we cannot breathe the dissolved oxygen. We'll get oxygen directly from the environment. Next, the rate of diffusion of liquids is higher than that of the solids. This is due to the fact that in the liquid state, particles move freely and have greater space between each other as compared to particles in the solid state. The rate of diffusion, as I told you, diffusion of liquids is higher than that of solids. Solid will not diffuse easily. I told you, two stones we cannot mix with each other, but the two liquids we can mix easily. So even nimbu pani, which I told, when you make sugar, tea, milk and water, we can diffuse, we can add. The rate of fifth one, next point, the rate of diffusion increases with the rise in temperature, as I told you in previous concept only. Sugar or salt dissolves faster in hot water than in cold water. If you take a sugar or if you add in a hot water, it will diffuse easily, because by increasing temperature, diffusion increases. If a cold water, if you add, we need to stir that with a spoon. So rate of diffusion increases with the increasing temperature. The next about